All right, good to see you all again. I hope it's been a good day. A lot of exciting stuff. Really grateful to be here with Satya, who really does not need any introduction. He is sort of the legend who is behind the great transformation of the greatest technology company of all time.
Thank you, Mark. Thank you.
Basically leading, pushing towards AI and cloud and all these important areas. And you've always been, from my perspective, a kind of friend and ally on the open source work that we've done. So I've really appreciated our partnership on this over time and the counsel that you've given me on how we should approach building out the Llama ecosystem and the infrastructure around that. So thank you for being here.
No,
we
absolutely.
Really
it's my pleasure, Mark. And I should say that my earliest memory is meeting you when I was working on Bing in 2008 or 9 and so on, and getting this massive lecture from you on
something that I was wrong about, which is even more embarrassing in retrospect. Yeah. No.
I remember this. I'll always remember this. You said, the web needs people. You need to see people. I'll never forget that. Like the ability to actually have a profile page everywhere you go. And that's a memory I have.
Well, I appreciate that you've forgiven me for that. Although the web does need people, so I guess at that level I was correct. But
or maybe agents now.
Yeah. Well, I think maybe both. Thank God. Yeah. But anyway, so you've said a number of times that this moment in technology around the growth of AI sort of reminds you of some of the important transformations in the past, from going to client-server and the beginning of the web and things like that. So I'm curious to unpack
so
that.
for me, I grew up when sort of the client was being born. I joined Microsoft just after Windows 3, and so I saw the birth of client-server, then the web, mobile cloud, and then you could say this is the fourth or the fifth, depending on how you count. And it's interesting, right, which is each time there is this transition, everything of the stack gets relitigated. And you get to sort of go back to the first principles and start building. I thought, like, even the shape of the cloud infrastructure for me that I built starting, let's say, in 2007, 8 to what have you, the core storage system for training doesn't look like the core storage system you built, or this workload of training, right? The data parallel synchronous workload is so different, let's say, Hadoop or what have you. So the fact that you kind of have to rethink everything up and down a tech stack with each of these platform shifts is sort of what I think we face from time to time. It sort of grows from what was there. The web was born on Windows, but it went far beyond that. That's kind of how I think about this as well.
Yeah, that makes sense. You've made this point a bunch of times around how as things get more efficient, it changes the way it works, and people just end up consuming a lot more of the services, right? And I guess one of the things that I'm curious about, right, because you guys are in this great enterprise business, and we don't have as much visibility into this, is sort of how you're seeing that play out around all these AI models, right? You're seeing, like, generation over generation, they're just getting so much more efficient and delivering more intelligence than the last generation. And obviously it's all happening super quickly, so I'm not sure kind of what you see in that, but
yeah, if you think about it, right, which is, we were all, a few years ago sitting around and saying, oh my, what's happened to Moore's Law? Is it over? What do we do? And here we are in some crazy sort of hyperdrive Moore's Law, right? And it's always been also the case, right, which is any one of these tech platform shifts has not been about one S-curve. It's been multiple S-curves that compound, right? Even if you take just the fact that the chips are getting better. People like Jensen or Lisa are doing tremendous innovation. Their cycle times have gotten faster. So let's say that's Moore's Law. But on top of that, everything at the fleet, the system software optimization, the model architecture optimizations, the kernel optimizations for inference, the app server, even the prompt caching, how good we've gotten in. And so you add all of that up for every 6 months, 12 months, you have a 10x perhaps improvement, right? And so when you have capability improvement of that rate and the prices drop at that rate, fundamentally consumption goes up. So I'm very optimistic that we are at a stage where deep applications can get built. And so these things where you have an orchestration layer with these agents, with multiple models, I feel like we're at that place. Because if you think about even the first generation of apps, they were very coupled to one model. But we are finally getting to multi-model applications where I can orchestrate, in fact, a deterministic workflow, an app, an agent that was built on one model, talking to another agent. We even have these protocols are helpful, whether it's MCP, whether it's A2N, whatever. These are all good things. If we can standardize a bit, and then we can build applications that are, taking advantage of, I would say, these capability building, but it has flexibility, and that's where I think open source absolutely has a massive, massive role to play.
Yeah, well, I definitely want to make sure we can get into discussing how to use multiple models together, and I think that there's this whole kind of concept of a distillation factory and the infrastructure around that you think Microsoft is well positioned to basically provide as there are multiple models. Maybe we'll come back to that in a minute. But before we do that, Microsoft obviously has been on this interesting journey around open source, right? And this is one of the big things that you did, under your leadership early on, was embracing it. And you had the early partnership with OpenAI, but then also were very clear that in addition to working with closed models, you wanted to make sure that Microsoft served open models well. And I'm curious how you think about that and how you think that the open source ecosystem is going to evolve and why that's important to your customers and how you think about that with all the infrastructure that you're building.
Yeah, it's interesting you ask that because I grew up, in fact, one of my formative jobs at Microsoft was also making sure that we had interoperability with the various flavors of Unix out there between NT and Unix. And that taught me one thing, which is interoperability is what, first of all, customers demand. And if you do a good job of it, that's good for your business, and obviously you're meeting customers where they are. And so to us, I think that's what has shaped my thinking when it comes to open. I mean, I'm not dogmatic about closed source or open source. Both of them are needed in the world. And in fact, I think customers will demand them, right? Even if any one of us has dogma, it doesn't matter, because at the end of the day, the world will break that way, which is there will be a need for it. So given that, I think, for example, there was SQL Server, there was MySQL, or Postgres. There's Linux, there's Windows. In fact, there is Linux on Windows. In fact, my favorite thing to use is WSL on Windows, because it just makes it easy to take a lot of the dev tools and deploy them on Windows. So overall, I think having a posture that allows you to mix and match these two things is super helpful. It also fits with what you just talked about, because a lot of my enterprise customers want to be able to distill, in many cases, models that they own. It's their IP. So that in that place where an open weight model has a huge structural advantage compared to a closed model. And so I do feel that the world now is better served with great closed source frontier models, great open source frontier models. And to us as a hyperscaler, this is a great thing, because after all, our job is to serve. Like if you go to Azure, you can get fantastic Postgres, you can get great SQL Server, or you can get Linux or Windows VMs. Same way, we want to have the choice available and great tooling around it.
Yeah, so what's basically kind of the pitch or the role that you see Azure playing for open source, but I guess across all of these? It doesn't need to be exclusively that. So for developers who are getting started, like where are the areas that you're trying to differentiate and be the best?
So the first thing is, it's not like an AI workload just has an AI accelerator and a model that, at inference time, right? Because the reality is, in fact, if you look at underneath any AI workload, there's storage, right? There is other compute than an AI accelerator, and there is a lot of dependency on the network and so on. So the core infrastructure, so for us in Azure, we want to build compute storage network plus AI accelerators as even infrastructure as a service that's world-class for someone who wants to be able to build the next generation of agents. Then above that, we're also building with Foundry an app server. Like, for example, every platform shift of ours, there's been an app server. How do you package up all the services, search or memory or safety, all of these services that are needed for someone, or evals. These are all things that every developer is trying to go do. So if you wrap them all in, frameworks for them, tools for that, that's, I think, the core. And then the other one is we are very focused on GitHub Copilot as the tooling as well. We're excited about sort of the progress that's making. So the combination of great tools, great app server, and great infrastructure for us is what I think is needed to accelerate application development.
Yeah, so how, you mentioned agents and increasing productivity, and that's obviously a huge theme for the whole ecosystem and community. I'm curious, how are you seeing that play out inside Microsoft? And then also, how are you seeing that, what are some of the most interesting examples that you're seeing with developers?
Yeah, I mean, I think the thing that obviously has been most helpful for us to see is what's happened with software development, right? I mean, there are a couple of things. If you look at even the evolution of GitHub Copilot, you started with code completions. Then you said, let's add chat. So that means you don't need to go to Reddit or Stack Overflow, and you could stay in the flow. So that is good. Then the agentic workflow, so you could just go assign a task. So those three things, if I look at even any one of us using it, you're using all three at all the time, right? So it's not like one substitutes the other. And now you have a proto SWE agent even. And so you can literally go high-level prompt, or you can just get a PR assigned to a SWE agent. So all four of those and the productivity gains, the biggest lesson learned there, Mark, is you got to integrate all of that with your current repo and your current developer workflow, right? I mean, it's one thing to build a new greenfield app, but none of us get to work on complete greenfield all the time, right? So you are working in a large code base with a large sort of set of workflows. So you got to integrate the tool chain, and that's the systems work that I think any engineering team has to do, and that's when you see the productivity. The same applies, quite frankly, for the rest of knowledge work as well. So when, in our case, with Copilot deployment for knowledge work, if you take sales, like one of the things I always describe is let's say I'm getting ready for a customer meeting. The workflow of how I get ready for an enterprise customer meeting has not changed since 1992 when I joined Microsoft, right? Basically, someone will write a report that'll come in email or will be shared in a document, and I'll read it the night before. Now I just go to Researcher and Copilot, and I get the thing which is the combination of what's on the web, what's internal, and even in my CRM, all done in real time. Right, but that's a change, and there's no need for somebody to prepare anything just because it's all available on tap. Yeah. So it requires you to change work artifact, and workflow, and that's a lot of change. And it happens slowly at first, and then all of a sudden, right? I saw that with the PCs, right? I think about how the world did forecasting before email and Excel. Like interop, the faxes went around. Yeah, I guess you never lived that world.
I was in middle school. Yeah, no, it's.
But there was a world where people sent around faxes, and people went and did interoffice memos, and then somebody said, hey, I'll send a spreadsheet in an email, and people will enter numbers. And that changed how people did forecasting. And that's, I think, what we're at the very beginning of. And you see it in customer service. You see it, I think, in marketing, collateral creation, content creation. So that's where we are. And you're seeing tangible progress and tangible productivity gains.
Yeah, interesting. In terms of the coding and how it improves that, do you have a sense of how much of the code, like what % of the code that's being written inside Microsoft at this point is written by AI as opposed to by the engineers?
Yeah, so there are two sort of things we're tracking. One is the accept rates itself, right? That is sort of whatever, 30, 40, it's going up monotonically. And it depends, like one of the big challenges we had for a long time is a lot of our code is still C++. C#, and C# is pretty good, but C++, it was not that great. Python is fantastic. So we've now gotten get better at that. So as language support has increased, the code completions have gotten good. The place where the agentic code still, it's sort of nascent. For new greenfield, it's very, very high. But as I said, nothing is greenfield in many cases. And so therefore, I would say maybe at this point, the PR, by the way, code reviews are very high. So in fact, the agents we have for reviewing code, that usage has increased. And so I'd say maybe 20, 30% of the code that is inside of our repos today in some of our projects are probably all written by software. What about you guys?
I actually don't have the number off the top of my head, but I mean, it's, I think, I think a lot of the stats that people say are still effectively of this like autocomplete variety.
Yeah.
But we have a bunch of teams that are working on basically doing feed ranking experiments and ads ranking and like very contained domains where you can study the history of all of the changes that have been made and like and make a change. And that I think is kind of an interesting area for us to work in. But the big one that we're focused on is building an AI and a machine learning engineer to advance the Llama development itself, right? Because I mean, our bet is sort of that in the next year, probably, I don't know, maybe half the development is going to be done by AI as opposed to people, and then that will just kind of increase from there. So I was just curious if you were seeing something similar or different.
I mean, to me, the SWE agent is the sort of the first attempt. So the question for us is, in the next year, can we get, let's take a kernel optimization, right? Will we get to sort of something like that happens? I think it's more likely. Whether it comes up with a novel model architecture change, probably not. So the question is, which task?
Yeah, no, optimizations, security improvements, that type of stuff, I think seems like it's pretty high opportunity. Yeah, no, I mean, we're also trying to solve a different problem on it because, I mean, you guys serve like a lot of developers and engineers, that's like your core business. Whereas for us, we're thinking about this more as a thing to improve our internal development and then improve the Llama models, which other people can use, but it's not something that we do the end-to-end workflow on in the way that you do. So it's always just interesting to hear how you're thinking about that.
Yeah, and the other thing for us is, to your point, our core business, in fact, Bill started the company as a tools company. And so to us, the interesting thing I think about now is maybe the way we should reconceptualize our tools and infrastructure, quite frankly, are the tools and the infrastructure for the agents to use. Because even the SWE agent needs a bunch of tools. And what shape should they be? What should their infrastructure, what should their sandboxes be? So a lot of what we're going to do is essentially evolve even what does the GitHub repo construct even look for the SWE agent?
Yeah, no, it's a very interesting concept. And I mean, I tend to think that like every engineer is effectively going to end up being more of like a tech lead in the future that has sort of their own little army of engineering agents that they work with. But yeah. So with that all in mind, I mean, I guess I mean, there are a few directions to go in. I mean, I'm curious, like, how, I mean, you mentioned your personal workflow for using AI. I'm curious how that's changed. I'm also kind of curious because you were talking about how Microsoft got started on this and the legacy there. But I mean, I guess there's always this question: if you were getting started as a developer today, building something, how would you think about which tools you'd be using?
I think that one of the biggest sort of, I'll call it, I don't know, dreams, pursuits, questions that Bill sort of inculcated in all of us was, what's the difference between, he used to sort of talk about it more like, what's the difference between a document and an application and a website? Right now, if you use Meta AI, ChatGPT, Copilot, what have you, it's unclear to me what's the difference between a chat session and then I go to pages in our case, like literally even coming down, I was like reading up everything about Llama 4, all the models, like literally I was just doing a bunch of chat sessions, adding it to a document effectively in pages, persisting it. And then you can go give it. I mean, since you have code completion, you can go, make it an app or what have you. And so this idea that you can start with a high-level intent and end up with what is an artifact that is a living artifact that you would have called in the past an application is going to have profound implications, I think, on workflows. And I think we are at the beginning of that. And that's what my dream is. So if I sort of say, as a builder of infrastructure and tools and as a user of it, these artificial category boundaries, not artificial, or these category boundaries that were created, mostly because of limitations of how our software worked, perhaps you transcend. In fact, the other thing we used to always think about is, why are Word, Excel, PowerPoint different? Why isn't it one thing? And we've tried multiple attempts of it. But now you can conceive of it, right? Which is you can start in Word and you can sort of visualize things like Excel and present it, and they can all be persisted as one data structure or what have you. And so to me, that malleability that was not as robust before is now there.
Yeah, interesting, makes sense. So one of the things in our conversations over the years that has kind of stuck with me, I feel like you have a very kind of, I don't know, it's a very like reasonable way of looking at the way that technology trends unfold. And there's all this hype around AI, and I feel like you've been able to kind of see through that and make very rational investments at each step along the way. And one of the points that you've made is that, okay, there's all this hype, but like really at the end of the day, if this is going to lead to massive increases in productivity, that needs to be reflected in major increases in GDP. And that this is going to take like multiple years, many years to kind of play out. And I'm curious how you think, what's your current outlook on sort of what we should be looking for to understand the progress that this is making, and how we would, and kind of like where you expect that to be over like a 3, 5, 7 year period?
To me, I think that's right, because to us, I would say it's a pretty existential priority, quite frankly. The world needs sort of a new factor of production and input that allows us to deal with a lot of the challenges we have. And the best way to think about it is, hey, what would it take, let's say, for the developed world to grow at 10%, right, which may have been some of the peak numbers during, let's say, the Industrial Revolution or what have you. And for that to happen, then you have to sort of have productivity gains in every function, right, in healthcare, in retail, in broad knowledge work, in any industry. And for that to happen, I think AI has the promise, but you now have to sort of really have it deliver the real change in productivity. And that requires software and also management change, right? Because in some sense, people have to work with it differently. People always quote what happened with electricity, right? It was there for 50 years before people figured out that, hey, we got to really change the factories to really use electricity differently, right? And that is the famous Ford case study. And so to me, we are somewhere in between. I hope we don't take 50 years. But I do feel that by just thinking of this as the horseless carriage is also not going to be the way we're going to get to the other side. So it's not just tech. Tech has got to progress. You got to put that into systems that actually deliver the new work artifact and workflow.
Yeah, well, we're all investing as if it's not going to take 50 years. So I hope it doesn't take 50 years. But all right, so we've kind of been, we're doing more of the technical questions up front and then getting to the big picture stuff, but I realized that we forgot to dive into the distillation factory thing and how you basically combine all the different, all of the different AI models that are getting built out for open source, and like what the infrastructure is that you think is going to be necessary to build that out. And I mean, this is something that you've talked about and I think have like a... Yeah,
to me, I think that to me is, I think, one of the biggest roles of open source, right? Which is to be able to take, let's say, some of your, even inside of the Llama family, taking a large model, and then to be able to distill it into a smaller model that has even that same model shape, I think is a big use case. And so to be able to then build the tooling for it as a service, and make the barrier to that. Like, I mean, to your point, standing up some of these large models is a bunch of infrastructure. Not everybody needs to do it, but if you do it as a cloud and then put the tools around it and the outcomes of distilled model. In our case, let's just say there was, let's say for every tenant of Microsoft 365, if they could have a distilled task-specific model that they can create as an agent or a workflow that then can be invoked from within Copilot. That, to me, is a breakthrough scenario. And people are already doing a lot of that, and we want to make that a lot easier. And so when I say distillation factory, that's the many-to-many type of, or one-to-many relationship I want between one large model, these distilled models that then get composed with a lot of other workflows inside of something like a product like GitHub Copilot or Copilot, because now they all support with MCP servers and so on, the invocation of these other agents.
Yeah, no, I've always been fascinated by this. I mean, I think that distillation is one of the most powerful parts of open source. And I think just because of our kind of respective parts of what we do here in terms of, we're training the initial Llama models, but we don't build out most of the developer infrastructure ourselves. I think having companies like yours that basically are going to build out this complex infrastructure. And we have models like the Behemoth one that we're working on, which I think it's really unclear how you would use it except to distill it into more reasonable forms.
Yeah.
So, I mean, even for us to use it ourselves, we had to build a bunch of infrastructure internally, even just to be able to post-train it. And there's no way we're going to run inference
and Maverick
on it.
is, you said, is distilled all of
a bunch of Maverick. I mean, the way that we basically got the performance on Maverick to be at the level it is, right? It's basically, it's multimodal, right? So it's leading multimodal. On the text performance, it's basically, up there with the other leading text models, but it's smaller, right? So I mean, DeepSeek is a bigger model than it, but on text, it's basically comparable. And then on images and kind of multimodal, it exists, and the others, don't. So, so that is, yeah. I mean, a lot of how we basically got that is, we have the pre-train of the Behemoth is done, and we're working on the post-training, but even just kind of getting it, I mean, the distillation, it's just it's magic. I mean, you basically can make it so that you can get 90% or 95% of the intelligence of something that is 20 times larger in a form factor that is so much cheaper and more efficient to use. So then the question is, okay, how do you make it so that that's available to people who are not as who aren't able to build up their own infrastructure, aren't as technically sophisticated to go do that? Because right now, I think that there's a relatively small number of labs in the world that could do that kind of either distillation or even operate models at that scale.
Yeah.
And I think by the time that this vision that you have is built out and it's accessible for most developers around the world, to be able to not only distill from a single model, but hopefully over time be able to mix and match and take different aspects of intelligence from different models where they're stronger. That just seems like one of the coolest things that I think is going to get built.
Yeah, no, I think that's correct. And so therefore, a little bit about what's the, if you have multiple models you're distilling from, and then what's the evals around this distilled model that you can then qualify, I think that's where we can do a lot of our tooling work, our infrastructure work, reduce the barriers for people to be able to have that flexibility. And the good news here is it's sort of already started. People have, there's existence proof of all this. It's just a question of can you reduce the barrier to building all of it. And the other thing is the speed with which people can move. One of the challenges to date has been I do something with one model, I fine-tuned it, a new sample drops. I need to move fast to the new sample. So that's the other thing that we have got to get good at, because you can't be saddled with what you did, because the world is moving too fast.
Yeah. Yeah, and also, I mean, developers just need things in different shapes. I mean, the Llama 4 shape of 17 billion parameters per expert was designed because the atomic unit that we have at Meta is an H100.
Yep.
Right, so we want to be able to run these things very efficiently on that. It's one of the things where, I mean, you look at some of the other models that have come out, some of the other open source models, it's like they're good intelligence, but sort of awkward to inference because of the scale, and maybe they're targeting different kinds of infrastructure. But we built this for kind of server production, but a lot of the open source community wants even smaller models. So to be able to build, the most popular Llama 3 model was the 8B. And We'll work on a smaller version. I talked about that earlier. The internal, we refer to as Little Llama, but we'll see what we actually ship at AS. But being able to basically take whatever intelligence you have from bigger models and distill them into whatever form factor you want to be able to run on your laptop, on your phone, on whatever the thing is, I think is just, I don't know. I mean, to me, this is like one of the most important things.
Yeah, and also I think you guys are obviously working on this, and I think that this is good to see, which is if we can get to these hybrid models, whether it's MOE dense plus thinking models that combine, and then you're able to get the latency that you want or the thinking time you want, and it's flexible. That I think is where we will all want to end up.
Yeah. All right. Well, maybe a good note to end on is just when you look at everything that's going on. I mean, I'm curious what gives you like the most optimism, or what are you most excited about over the next period for what developers are going to be doing over the next few years?
Yeah, I mean, look, I always take my inspiration from that Bob Dylan line, right? Which is either you're busy being born or you're busy dying. It's better to be busy being born, and especially at a time like this, I think what gives me optimism is, even with all the various constraints, it turns out software in this new form of AI is still the most malleable resource we have to use to go solve these hard problems. And so that's what gives me the optimism. And I also sort of say that's the call to action, I think, for the people in the room and for all of us, is to be able to sort of take the opportunity to lean into this, but then also build solutions. When I look at whether it's an IT backlog in a company or the unsolved problems in the real world, both of them need something new. And in order to work that, and that's where I think the greatest benefit of all of this tech is, and it'll only come down to developers in particular being able to go at it fearlessly.
Awesome. All right. Well, thank you, Satya, and thank you all for coming out. This has been an exciting day, and I'm very excited about what we're all building. So.